Steph from WITS, and she'll be looking at some drone mag for cavities.
Cool.
Thanks, Steph.
Thank you.
Okay.
I will. Hold on. Okay. I was going to say, you don't expect to see magnetics when you're talking about dolomites and cavities, but Ilse destroyed that because she showed some magnetics. So, oh well, there goes my opening line. So this was so this is really just to make you aware of a drone program that we are starting up at WITS University and some data that was collected in association with it. And it's all over the Rising Star Cave System. So a show of hands, who's heard of the Rising Star Cave System? I won't ask you any questions. Okay, we've got some hands. If you're from WITS, you better have heard about it. Okay, so the drone program itself is called the MAG ASSEGAI, Drone Magnetic Platform Collaborative Program. And I'll talk a bit more about the different partners involved with it. Okay, and so you've got Exige or Coleopter, and so this is a French-Canadian company, no, sorry, French-Australian company, who have donated a platform to us. So it already has a magnetometer installed on the drone platform. So WITS, they've donated the equipment to us. It'll go on our asset register with our insurance, and we're bringing along students. But then we've actually got a third partner, which is the University of the Free State. So Martin Clark at the University of Free State has a drone program going there already. And so we really just wanted to lean on his expertise. And he himself is a drone pilot. And so again, I suppose this is all shown at the bottom here. And so it's really just how are we bringing together industry and academia to not just train students, but also just advance the sciences as well. So on the left, there's Martin on the day that he got trained with the drone. We will see if the video works. Okay, so you can see the drone going up, and it pauses for a little bit. And there is a small boom over there that will come down, and that's the magnetometer. So you will remember the drone you saw earlier from SkyTem. It was hanging below the drone, whereas, oh, it's fine, it died. Okay, there you are. So you can see there's the magnetometer coming down, it gets calibrated, and then it moves off. So I think often it's towed below the drone to avoid noise, but the guys at Exige and Coleopter have managed to get rid of a lot of this noise, and so it's easier to transport instead of having to tow something below the drone. Oh, sorry. There we are. So I mean, obviously, as we all say with drones, we say low cost, but then you don't know about all the money you have to pay to get it legalized on the system. So, but lower cost, weight and power requirements. Like I said, they've managed to compensate for a lot of problems that challenges other people have had with putting magnetometers on drones. And they've got quite a nifty, quick calibration and drift error correction. And that's I've forgotten his name now, but this is the pilot who developed it through Coleopter, and there's Martin on the right-hand side. And so I had to give you some example of data. And so the data that they collected was not the exact system that WITS has, but a very similar system that was collected over the Rising Star Cave System. And so it was discovered in 2013. Does anyone remember who discovered it? And you can't say Lieberger. Yes? Oh, I thought it was Lieberger's son who discovered it. Oh, what was a tax consultant doing looking for fossils? Is that how boring tax is, that you go looking for fossils? But you might also remember that the initial exploration there was a team of very dainty females because it was such a small system, a cave system, that only small females could get inside. I think it was all an advertising ploy, but anyway. But the main thing is that the fossils that came out, it really challenged the evolutionary timeline. I know there's been a lot of concern and forget what the word is since. I don't know if anybody's watched the Netflix series that they had about it. And there's a lot of debate around it, but nonetheless, it was quite a revolutionary discovery. And so at the time, you can see here this black triangle here on this Momani subgroup group, which is your dolomites, this blue. This was where they were looking for the cave system. Well, they discovered the cave system. And so Sue Webb, at the time, who will be speaking tomorrow, organized Laurent to bring his drone and fly in this region. Because you'll say, but dolomites aren't magnetic. Well, actually, you've got this Rooihoogte formation, which I think, Ilse, you also mentioned, and it produced quite a red soil on the ground. And so Sue took a susceptibility meter, took some measurements, and it was quite magnetic compared to the surrounding rocks. So just wanted to see, what are these magnetic sediments going into the cavities, and can it help us map where the cavities are, maybe the cave entrances? And also you've got your Hospital Hill subgroup. That could also be the shales are quite magnetic. Just depends where everything's moving in this region. And so this is just a table of the samples that they took. You can see the number of samples. And on the left-hand side here, the susceptibility measurements of these different rocks. So there's chert, dolomite, capped dolomite, limestone, and soil. And the soil is drastically higher susceptibility than the surrounding rocks. And this is a Google Earth image on the right-hand side. And so what I've done is I've taken this image on the left from the paleontologists, which shows the cave system here in gray. And then you've got these chert layers in yellow and these fractures in green and red. And so I've overlain the main information on the Google Earth image here, with the cave system being outlined in white and the entrances in yellow. And then these fractures, which actually, if you take them off, you can kind of see them on the Earth's surface with the vegetation. And so the main thing was, well, can we find these entrances with this drone magnetic data? Because if it's such a difficult entrances that only skinny females can get in this area, if you could find a larger entrance in this region for all the men to go in, it would make their lives easier. So that was, we were trying to help them to equal gender. Okay, so these are the two, well, technically 3 surveys that we did. So if you can see behind me, this dark outlines the cave system. In purple and in yellow are a ground survey that we did with the students. I also helped out with that at the time, just to see how does the ground data compare with the drone. This blue survey here was a much smaller area that they covered with the drone, higher resolution. And then this large black survey was the larger drone survey that they did. And you can see there was line spacing varying from 20 meters to 10 meters. And I think we didn't put the flight height, but it was around 20 meters. And something that I got, my claim to fame on the ground survey was that I had my hat on that had a metal rim around it. And so we got back from the field that day and the data was a disaster. And so that was the other one benefit of the drone, is you don't have silly field crew members with magnetic hats. Oh, sorry. Okay, so this was the large drone survey that they flew. So it was this 20-meter flight spacing. And so this is the data in the background. You can see the scale here is going from -30 up to 20. So not very big anomalies, 15 nanotesla anomalies. The black outline is the cave system, and these dashed lines are the faults or fractures that they mapped on the surface. And so these small little black lines are the cave entrances. And so you can see the resolution definitely is not enough to say anything about these entrances, but you could quite confidently say that we are somehow seeing, or we are seeing this fracture network in the region, possibly this one also extending up here. If we look at the smaller drone survey, the large survey was flown approximately northeast to southwest, whereas this one is west to east in this direction. And so I would say it's too close to the fracture direction to really pick them up. And sadly, I'm not sure why they chose this location for the small survey, because there's actually no mapped entrances in this region to compare them to. So I wasn't involved with that decision. But I mean, you can really see how in the previous survey, with the flight lines being northeast, southwest, you're picking up these east-west features, whereas as you're moving here, you've got east-west flight lines, you're missing out on a lot of these east-west features. And then this was our ground survey, and this is not my bad data. This is the good data, but you can see how noisy it is. It's really, I mean, our anomalies here are about 100 nanotesla, so they're not small, but it's quite hard to correlate anything because there's so much going on. If you then look at these cave entrances, none of them seem to correlate particularly with any anomaly. So we did say that actually that aspect of trying to find this correlation didn't seem to be successful. trying to understand the fracture networks. You are seeing a little bit of a correlation over here with this lower fracture in 2016, possibly also up here from our 2015 data. But in general, it was harder to see, not as clear as on that larger drone survey. I did upward continue the ground data, which helped reduce the noise a bit. So up here, we've got the large drone survey, the small drone survey, upward continued 2015 and 2016 data. But still, you can maybe see something in the ground data. But I felt this large drone data, we got the most information out of. You can equally go and filter the drone data, and it really seemed to help bring out these fractures. So while we see, Well, it seemed that the small drone survey and the ground survey didn't seem to provide too much information about the fractures. The large survey here did seem to help map or extend these fractures further up. But we definitely said it was a fail on trying to find the cave entrances, that it was just too small to find those surveys. But that said, I mean, if you know that your fracture is extending in this direction, that would be an ideal place to go explore to see, are there other cave entrances up here? Does this cave network extend in this direction? So, I mean, it did provide some sort of information to the paleontologists. And so we didn't actually do GPR in this area, but about 5 kilometers away, you're still in the Dolomites, in the cradle of humankind, and Wits actually owns a quarry in that region. And so this is Sue Webb. You can tell her tomorrow you enjoyed seeing her in her picture. In the quarry, they actually found an entrance to a cavity that only Sue would climb inside of. And so you can see the size of these entrances. And so we don't have drone data over this quarry. The idea is now that our drone is becoming operational, we will go fly over this quarry and see if we pick up similar features. But we did take our GPR, our ground penetrating radar, and collect some profiles in this area. So I've only got a few more slides to just show you. Sorry for my fracture. The first time we went out, we had just bought our GPR and the geophysicist didn't talk to the geophysicist and ask the other ground penetrating radar guys to come with, but we took students and we tried to figure out how it worked. And we must admit, we were quite confused what we were looking for because we didn't actually have a known cave entrance. So we got a lot of strong reflections. But then thankfully, the next time we went out, they had found a cave entrance and we did some profiles over this region as well as over what we said was a fracture because you had a lot of vegetation in it. And it gave us a great confidence in the data that we were seeing. So this is a Google Earth image here, and this star is that cave entrance that I've just shown you. And this is this possible fracture where you've got all the vegetation. So we did 3 profiles along it, and you can see these are just 2 of them. And this super strong reflection here where we hit this cave, which surprisingly is just west of the fracture. But the strong reflection then gave us confidence on what we were seeing in the other data elsewhere. And interestingly enough, these fractures extend down onto this north-south road, and we could go back and look at our data here, and actually at this exact point, there were strong reflections as well, now that we knew what we were looking for. So 2 very the GPR, I mean, we know that it works well in areas like this, but the magnetics was surprising that it was so useful in an area like this. So yeah, in general, we did manage to map some fractures with the drone magnetics, but obviously the flight direction was very important in order to help us map further where these fractures were extending. So we're assuming that we're mapping these fractures because the magnetic sediment's being eroded into the dolomite area. It's filling the fractures, and that's why we're picking up this magnetic signal here. And so it can guide us for future exploration. But like I said, sadly, the original idea of finding cave entrances didn't work. So the skinny ladies had to keep going down the hole. But I think that said, I think more people did go down eventually. Thanks so much.
Awesome. Thanks, Steph. Are there any quick questions for Steph?
Steph, knowing that I'm a student and seeing that the ground MAG data didn't show much detail, are you going to integrate the drone system into field school?
If you can pay me lots of money. Ideally, yes. So I suppose I didn't end off where we are there. So after them having brought the drone out last February, we did our training last February. We've only just got our drone license, like gone through that it's actually onboarded and can operate legally, because that was one of the requirements. So in South Africa at the moment, many people do operate drones without being on a license because there's a lot of grey area. But one of our prerequisites for getting the drone donator was it had to be done legally, and WITS insurance wouldn't cover it otherwise. So we are looking at having paid 50,000 Rand. We are only covered for 3 months on the license. So that is the cost that we're looking at. The reason why we went with the University of Free State is we now have Martin Clark who will fly, obviously linked to his research, and his costs are free. Otherwise, you actually got to pay a pilot to come out and fly for you. So, I mean, the costs are ridiculously prohibitive. We are talking to SRK to try and get some sort of collaboration going there. But yeah, it is quite difficult. So we would have done field school for Martin because that's his research interest, but we'll have to see in future.
Awesome, thanks. I think we'll end there.